Hey everybody, Mr. Wagner here. Today we are going to learn about analog sensors. Analog sensors. So, if you were to go into topics in Blackbaud, we are on day 5. The slideshow that I'm doing is right here. The video that I'm doing is right here, and copy and paste code is right here. Oh, I didn't mean to click on that. Anyway. So we're going to look at the slideshow. We'll start with that. Analog sensors. Hey guys, shut your laptops. Okay. Okay. So we're going to talk about analog versus digital. Okay. Um, Digital basically means 0 or 1, true or false, 0 or 5 volts. Okay. So whenever somebody says digital, we are always like 0 or 1 or 5 volts or true or false, something like that. Now, analog means it could be any number in between 0 and 5 volts. Okay. Any number. Okay. So instead of it just being 0 and 5, it's any number between 0 and 5 volts. Oh, here we go. I forgot about this. You all can fill in this as we go through this. I know. Here we go. I bet you would too. Okay. Okay. So, in your own word, the first thing on there is in your own words, what's the difference between digital and analog? Right up there. Remember, analog electrical signals are basically any signal in between 0 and 5 volts. Is everybody cool with that? Does that make sense? Okay. So the real question is how do we make a computer make sense out of analog signals? Okay. How do we make that happen? And the answer is we are going to use what's known as an A to D converter. Okay? A to D converter. I think that's one of the things on the worksheet. So an Arduino's A to D converter turns analog to digital numbers. Okay? So, and they write it like that, A/D. Now, if you notice over here, see where this says analog in? Analog in? Those are your analog places. And if we look on ours, it's going to be a little bit different. But you see right here, it says analog in, A0 all the way up to A7. Okay? Actually, it's all the way to A15. There's a lot of analog ports on this particular board. Okay? Now, let me show you how this works. Okay, first off, so a lot of the analog signals that we can look at on our robot are like temperature and brightness, sound levels, humidity, electrical voltage, etc., including oh shoot, I just had it. Where is it? Oh, here. See this contraption? Let's tab over to it. See this thing right here? This little joystick? This thing comes off. This little joystick here is an actual, you can use it to make an analog signal. So like for instance, if you were going to make a small video game, then you would have to use the analog ports, which is what I did on this. Okay, here's like a little joystick, right? Okay, so analog is joysticks, temperature, pretty much anything that's going to generate a value that's not that is not a 0 or 1. Okay? Not a 0 or 1. Any questions on that? Okay. So, in order for us to do that, we need to set up what's known as a voltage divider circuit. Okay? And in the simplest terms, a voltage divider circuit is basically two resistors, and you have 5 volts on one end of the circuit, and then you have two resistors, and then we have 0 volts here. So the voltage that's here is basically, it's kind of like a prorated value between the two resistors. So if both of my resistors are exactly the same, then my voltage here would be like 2.5. Okay? If this resistor was less than this, then it's almost like my voltage would be up higher. It'd be maybe 4 volts. And if my resistor here was bigger than this one, then maybe it would be like 1 volt. So it's almost like a proportional sort of thing. Does that kind of make sense? So anyway, basically we're setting up two different resistors, and then we plug this voltage here, and that goes into our analog pin, okay? And our analog pin, the computer inside the Arduino, can turn that voltage, whatever that voltage is, into a number, okay? Now, we are going to use a couple of very fancy little electronic pieces. One is called a thermistor, and it looks like this. And the other is called a photocell, and it looks like this. And thermistors and photocells vary the resistance based upon what they're doing. So a thermistor changes its resistance based upon whatever temperature is in the room or whatever. And a photocell changes its resistance based upon light levels. Okay? Now, let me show you. Let's go here. And this, my friends, is it's kind of hard to see, but that is a thermistor. Okay? Little teeny thing. And this guy right here is a photocell. If you look at the photocell, the top of it almost looks like a zigzag. See that? I don't know if you can see that real well. Well, you'll start playing with it, so it'll be okay. And let's go back here. Okay, so let's go back to our voltage divider circuit. And remember this voltage, whatever that voltage is proportional to whatever, it's like whatever's in between these two resistance values. So on our circuit, we're going to make R2, not R2D2, but R2 be 5,000 ohms, okay? And then we are going to change R1 to be either a thermistor, or a photocell, okay? So if our thermistor is up here and R2 is 5,000 ohms, then depending on what temperature it is, this resistance is going to change, and therefore our voltage is going to change. Does that kind of make sense a little bit? Just nod your head. You'll see how it works. And similarly with the photocell. Okay, so this is what our circuit looks like that we are going to build. I'm going to go ahead. Well, let's go ahead and persevere in just because I'm recording. Okay, but we'll come back here and you'll be able to build this circuit. Okay, I'm going to scroll over to here, and this is my thermistor. See it? I'm going to plug it in between here and here. This is my photocell, and I'm going to plug it in between here and here. Okay. Now, if you remember, if we look at our circuit again, darn it. If we look at our circuit, we have one side of the thermistor going into power, the 5 volts. See, 5 volts goes here into here. The other side goes through the resistor to ground, okay? So ground up to one side of, I hate this. Sometimes I hit that button. So the ground goes from the resistor all the way up through the thermistor to power, okay? Which if you think about our previous thing, see, we got power going through the thermistor and then through the resistor and then to ground, okay? So if we look here, we got power through the thermistor, through the resistor, and then to ground. And then in between the resistor and the thermistor, that goes to analog 0, okay? And very similarly, that happens with the photocell, okay? So let me go ahead and hook that up real quick. You'll see that it's not terribly difficult. Let's see, we go ground to one side of the photocell. And we're going to go ground to one side of the thermistor. Okay. We are going to go this to power. Okay. Power is like right there on the blue, on the yellow. We're going to go this one over to power. I'm going to put it over here just because it's out of the way. Okay. And then we got 2 more signals. We are going to put this one, this is in between the photocell and the resistor. So here to here, this goes into A1. And this one goes in between here and here. And we're going to set that to A0. If I can, okay. All right, now it looks like a big jumble of wires, but electricity doesn't care if you got a big jumble of wires, okay? All right, so pretty cool so far, right? You think you sort of grasp that? Hopefully you do. If not, you can rewatch the video. Obviously, I'll come and help you. Okay, so let's go to our next. This is our code that we are going to be putting in. And if I go into, here's copy and code, code to copy and paste. If I click on it, I can just copy this code real quick. Control C to copy. I'm going to need Arduino up. So I'm going to pull up my Arduino code. It would probably help if I plug this thing in too. Okay. Well, look at that. I had already had it up there. So I'm going to just hit paste just so you can see what's going on. Now, if we look at this code, we set 2 variables. One's called thermistor and one's called photocell. Ultimately, the thermistor is connected to A0 and the photocell is connected to A1. We're doing a serial begin, so we're turning on the serial port because we're using that serial monitor. the main command we're using here is thermistor equals analog read A0. So basically, analog read says, look and figure out what the voltage is on A0 and give me a number. And then that number goes into a thermistor. That number is an integer for those of you who've done some computer programming. And then lines 18 through 21 basically just print out what the thermistor in the photocell is. And then we delay a little bit. So I'm going to go ahead and hit run, upload. Okay. And let me put on this. Kind of hard to see. Let's see if we can go. I want to go like half screen. And I'm going to go half screen over here. Okay. So I don't know if you can see this, but right now my thermistor is at 308. Can you see that? Now, if I put my hand over the 308, I'm just putting my finger on that thermistor. What did it go up to? Can you see that? It says 400. So the warmth of my finger brings that up to 400. And if I let go of the thermistor, you'll see that it goes down. Okay, so say for instance you're building a robot engine and you're worried about the engine overheating. Well, maybe you would put a thermistor on that robot engine to be able to tell whether it's gotten too hot or not. Okay, thermistors get used everywhere. Like for instance, in an air conditioning system, you might have a thermistor. If it gets too hot, it would open a valve to make it cooler, or open a flap on an air conditioner. Now, notice how my photocell is at 560. If I put my finger over the photocell, look, now it's like 147. Do you see that? Okay. So I can tell the difference in light levels. Okay. So maybe, for instance, I would have, say I had a dark room, where I did photography development or something like that. Well, maybe I would have a photocell in there to say, if it's dark, turn on a warning light so nobody comes and opens the door and exposes my film. Okay, so you see where some of these things come in. Now, I want you to look at this code a little bit. On lines 25 through 28, I put if the photocell is less than 200, okay, then I also want to write the word lights are off. Notice right now I have slashes in front, okay? Those slashes are comments. So right now the computer doesn't even care about those. But if I get rid of those comments, then we can put that code in. And when I run this, now I want you to notice it says, still says the same stuff. But now when I put my finger over, now notice it says the lights are off. Okay? So what I want you to know about that is right here, this statement, I can say if a variable is less than a particular number, then I can do something. I can turn on a light, I can move a servo, I could send an email, I could do all kinds of things. So that if-then statement allows me to do that, okay? Does that kind of sort of make sense? I hope. Okay, let's see what else I had on my on this presentation. Okay, slideshow. Okay, so analog read basically looks at a particular pin. So the way you would do it is you would say int, which stands for integer, thermistor is 0. So I'm saying this next line of code says I'm taking that variable thermistor and I'm putting in whatever I'm reading, whatever value I'm reading off of analog 0. Okay? So that's how that works. And then if I use the if statement, if the photocell is less than 200, then we're going to turn the lights on. What kind of things could you make with this knowledge? What do you think? I need 3 ideas. Rio, what idea? I'm putting you on the spot. Huh?
I don't know.
You don't know? What do you think you could use a temperature sensor for? For your PC. Exactly. You could tell if your CPU is overloading because you've been playing too much Call of Duty, right? Okay. What do you think you could use a light sensor for? For your PC? Well, maybe. I mean, you could put a light sensor in your room and do things. Okay. So your assignment today is to build the circuit, which is not terribly hard, program the Arduino, which is a copy and paste, and then do that half sheet worksheet and make sure that I can see what you've done. Since Ryan's not here, it looks like we got basically 2 groups of 3. So let's just do 2 groups of 3. No. Now it's Rio gets to work by himself. Oh. Okay. So you guys know what you're doing? Okay, very good. I'm gonna hit stop.